Today we have to discuss the next topic of the CAE. It's a meshing techniques. Firstly, introduction of meshing techniques. Need of meshing technique. The basic concept of FEA is based upon the calculation for any limited number of points and interpolation of result of for the entire domain. Means FEA stands for finite element analysis. Finite element analysis means what? FEA is useful only in the if body having limited finite number of element in the body. Then and then only you have to calculate the any problem solution by using FEA. Okay, means FEA itself says that finite element analysis. So you have to require to cut down that whole geometry or whole surface or whole volume into the small number of pieces like elements, and two element joint connection is a node. Means you have to convert your whole body into elements and node. Then and then only you got the exact result to the problem. Any object in the space has infinite degree of freedom and it's just impossible to solve the problem. If we reduce the degree of freedom from infinite to finite with the help of discretization. Discretization means, just I have to say that it's convert the body into the small number of elements and two elements connected at the node. It's called meshing. Meshing. Meshing is the part of the finite element method and refer mostly to the complex mathematical procedure used in solver. FE having at here you see that there will be the element, there will be the nodes. Dotted are the nodes and connected to two nodes, it's a element. Means any engineering problem or any engineering problem you have to solve by using the FEA. Okay, but in FEA you have to require the meshing for discretization of that whole body or whole surface with in the small number of elements and node. Types of element. Types of elements: 1D element, 2D element and 3D element. In 1D element there will be the beam, two noded, three noded beams are there. In 2D element there will be a triangle, there will be the quadrilateral. Means if there are the two dimensions element, then we will say it is a 2D element. In 3D element there will be the three dimension element. Hexagon, then trigon, just like that. There will be the 3D element. 4 noded, 8 noded, 6 noded, 10 noded. There is a number of nodes present in that element. On the basis of that, we have to divide that element into the 4 noded, 8 noded, 6 noded, 20 noded, just like that. It's a types of element. In element selection criteria, there were three types of main things we have to study. First is the geometry, size and shape. Then second is the types of analysis, and third one is the project time. Geometry, size and shape, if it is a 1D, 2D or 3D geometry. Mappable or non-mappable means, mappable means simple geometry, non-mappable means complex geometry. If there is a shape is a complex shape, then we will go for the another types of machine. If there is a simple type of shape, then we will go for the another types of machine. Types of analysis. Type of analysis means which types of analysis you have to: static, static analysis, linear, non-linear analysis. Or third one is a project type. Project time means product life cycle time. Solution runtime means in how many you have, how much time you have. Means if you converted any geometry in number of pieces and the element size is very small, then runtime of that solution will be also very high. At that time, you have to run the solution in very long time, and this is not acceptable by any company. So you will be required the exact time of your solution, means exact how much time you have to having for the solution. Element selection criteria, types of element. The type of element to be used, such as first order or second order. Number of nodes, the number of nodes in the element. Degree of freedom, the degree of freedom of the element. Formulation of the element. Integration method, the integration method of the element. Means these are the element selection criteria. On that basis, you have to select the perfect element size and perfect meshing type for particular geometry or particular volume. Element selection based on the type of analysis. If there will be the only structure or fatigue analysis, then chord, X are preferred for the analysis. Then if there is a crash or nonlinear analysis, priority of mesh to flow line bricks element over the tetrahedron. Okay, then fourth type is mold flow analysis. Then triangular elements are preferred for the quadrilateral. Then last one is a dynamic analysis there. When the geometry is a border case as per the above classification of 2D and 3D geometry, 2D shell element are preferred over the 3D. Means if dynamic analysis is there, then we will be selected the 2D shell element. Okay, these are the mesh element selection on the basis of types of analysis. Mean which types of analysis you have to require. Then based on time allotted for the project. When the type and appropriate selection of the element, mesh flow line, good mesh quality is recommended. Means if time is very less, then you will go for the minimum time or good mesh quality. But sometimes due to very high, very tight deadline, analysis is to force to submit the report at earliest. For such a situation, automatic or batch meshing tool will be used. For 3D meshing, tetras preferred over the hexas. If assembly of several components is involved, then only critical parts are meshed appropriately. Other parts either coarse mesh or represented the approximately via 2D elements, spring connected masses, etc. Means if assembly of several components are there, means what, जब वहां पे बहुत सारे कंपोनेंट की असेंबली आएगी और जब असेंबली आपको सॉल्व करने करेगा, तब वी हैव टू कंसीडर दैट हम लोगों को जो क्रिटिकल पार्ट है वहां पे मेशिंग अच्छे से करना है. अदर पार्ट के लिए आप गो फॉर द कोर्स मेशिंग, मीन्स सिंपल मेशिंग. और वो जो एलिमेंट है, समझो स्प्रिंग एलिमेंट है, तो आप 1D बीम एलिमेंट यूज करके आप कर सकते हो. क्योंकि क्या होता है, जब आपका नंबर ऑफ एलिमेंट्स बढ़ता है, नंबर ऑफ नोड्स बढ़ता है, तो रन टाइम भी बढ़ता है. अगर आपको विद इन अ टाइम आपका प्रोजेक्ट कंप्लीट करना है और नंबर ऑफ एलिमेंट्स और नंबर ऑफ नोड्स बढ़ जाते हैं, तो नंबर ऑफ डेज भी बढ़ जाएंगे आपके रनिंग के. मतलब जब आपको जो आपका कंप्यूटर है वो जब सॉल्व करना चालू हो जाएगा तो नंबर ऑफ डेज भी बढ़ जाएंगे. तो इसलिए हम लोगों को पहले प्रेफर करना है कि एग्जैक्टली अपना रन टाइम कितना आएगा, और वो रन टाइम इट इज ओके फॉर योर डेडलाइंस. मीन्स आपको प्रोजेक्ट कब तक सबमिट करना है, वो सबमिशन के लिए आपके जो डेडलाइंस है वो फॉलो हो रहे तभी आप वो मिशिंग यूज करोगे. अगर नहीं हो रहे तो आपको फिर सोचना पड़ेगा कि इसमें टाइम में, इतने कम टाइम में हम लोग प्रोजेक्ट कैसे कंप्लीट करेंगे. तो उसके बेसिस पे भी हम लोग एलिमेंट सिलेक्शन लेते हैं. जैसे कि यहाँ पे लास्ट में एक एग्जांपल दिया कि नंबर ऑफ क्रिटिकल पार्ट्स आर देयर, then only you have to choose the one of the part which is very critical. आपको वही पार्ट चूज करना है, उसके ऊपर ही अच्छे से मैचिंग करना है. अदर पार्ट के लिए आप एक तो डायरेक्टली 1D और मैशिंग यूज करो या फिर कोर मैशिंग यूज करो.